Hello students, Assalamu alaikum and good morning to you all. I hope you all and your near and dear ones are in the best of health. This is APS 7 Streams online teaching system and I am Faraz Fayaz, physics teacher for class 9th. Today I'll be delivering the third lecture from chapter number 4. Before we move on to our today's topic, let's have a quick recap of the important things we learned in lecture number 2. If you haven't watched lecture number 1 and 2, I would strongly recommend you to watch the previous lectures before watching this video. In the previous lecture, we learned about clockwise and anti-clockwise torques, how they work, and learned their examples. But our main topic was principle of moments, which stated that a body is balanced if the sum of clockwise moments acting on the body is equal to the sum of anti-clockwise moments acting on it. We also discussed daily life examples related to the topic and also solved a mathematical example which helped us in clearing this topic more. So now let's move on to our today's topic, that is center of mass. Center of mass is defined as the point where the whole mass of the system is lumped. It is observed that the center of mass of a system moves as if its entire mass is confined at that point. A force applied at such a point on the body does not produce any torque in it. That is, the body moves in the direction of net force F without any rotation. Now let us consider a point O. Consider the point O anywhere between point A and B such that the force F is applied at point O as shown in figure 4.17. If the system moves in the direction of the force without rotation, then point O is the center of mass of the system, which means that whenever we apply force on this particular point, there will be no torque. The object will move straight in the direction of the force applied. Now students, does the system still move without rotation if the force acts elsewhere on it? We'll learn that as well. Now consider the upper diagram. Let the force be applied near the lighter particle as shown in figure 4.18. The force is applied near this blue particle or blue end. The system moves as well as rotates. Let the force be applied near the heavier particle as shown in figure 4.19. In this case also the system moves as well as rotates. So center of mass of a system is such a point where an applied force causes the system to move without rotation. Our next topic is center of gravity. A body is made up of large number of particles as illustrated in figure 4.20. You can see here a body which is made up of small particles that are in huge number. Now the point is, what is center of gravity? Center of gravity is basically a point where the whole weight of the body appears to act vertically downward. That point is called center of gravity of a body. It is useful to know the location of the center of gravity of a body in problems dealing with equilibrium. Okay, center of gravity of some symmetrical objects is shown in the figure. The center of gravity of some symmetrical objects like a rectangle, a square, a triangle, or a sphere are all shown in the figure. The center of gravity of a uniform square or rectangular sheet is the point of intersection of its diagonals, as you can see in this figure. The intersection point of the diagonals is basically the center of gravity of a square and a rectangle. The center of gravity of a uniform circular disk is its center as shown in figure 4.22b. Here you can see it. Similarly, the center of gravity of a solid sphere or hollow sphere is the center of the spheres as shown in figure 4.22b. You can see here. Okay, the center of gravity of a uniform triangular sheet is the point of intersection of its medians. You have to draw median at each point, and the point of intersection of the medians is the center of gravity. Next is, you can see in this uniform solid hollow cylinder, the middle point of its axis is basically the center of gravity. As far as this scale or rod is concerned, the center of gravity of a uniform rod lies at a point where it is balanced. The balance point is its middle point, or you can call it G, is its center of gravity. Okay, moving on to the next slide. Now, students, what will be the center of gravity of the object having irregular shape? Consider the center of gravity of an irregular shaped thin lamina. A simple method to find the center of gravity of a body is by the use of a plumb line. What is a plumb line? A plumb line consists of a small metal bob, lead or brass made, supported by a string. You can see in this diagram a metal bob which is made up of any metal like lead or brass, and it is supported by a string. This is known as a plumb line. When the bob is suspended freely by the string, it rests along the vertical direction due to its weight acting vertically downward, as shown in figure. In this state, center of gravity of the bob is exactly below its point of suspension. Now we'll perform or understand a simple experiment. Take an irregular piece of cardboard, make holes A, B, and C as shown in this figure. A, B, and C. These are three holes which you are going to make near its edge. Fix a nail on the wall. In this diagram, you can see a nail here. Fix a nail on a wall. Support the cardboard on the nail through one of the holes. Let it be A, so that the cardboard can swing freely about A. So the cardboard can swing freely about its point A. The cardboard will come to rest with its center of gravity just vertically below the nail. Vertical line from A can be located using a plumb line hanging from the nail. Mark the line on the cardboard behind the plumb line. Mark a line behind the plumb line like this. Repeat it by supporting the cardboard from hole B. Now next time you will move point B towards left side and fix a nail at point B. Then draw the line from point B. Then you will again in the third step you will place a nail on point C by moving point C in this direction, in the upward direction, and you again draw the lines behind the plumb line. The line from B will intersect at a point G. The line from B will intersect at G. The line from point C will intersect at point G as well. Similarly, now note that this line also passes through G. It will be found that all the vertical lines from hole A, B, and C have a common point G. This common point G is the center of gravity of the cardboard. Okay, students, our next topic is couple. When a driver turns a vehicle, he applies forces that produces a torque. Whenever he moves his steering wheel in the clockwise direction or in the anti-clockwise direction, he basically produces a torque. This torque turns the steering wheel. These forces act on opposite sides of the steering wheel. You can see here, one is acting in the upward direction and one is acting in the downward direction. These two are unlike parallel forces, having equal magnitude but opposite in direction. These two forces form a couple. The exact definition of couple is given in the pink box. A couple is formed by two unlike parallel forces of the same magnitude but not along the same line. Example of couple: a double arm spanner is used to open a nut. You can see a double arm spanner. A and B are its two ends or arms. Equal forces, each of magnitude, are applied on ends A and B. Equal magnitude force is applied at point A and at point B, but their direction is opposite. These forces form a couple that turn the spanner about point O. The torques produced by both the forces of a couple have the same direction. Thus, the total torque produced by the couple will be F multiplied by OA. Here F is the force, OA is the moment arm at point A. And then from point B, F is the force applied and OB is the moment arm. Taking F common, you can write it as F OA plus OB. And you can write OA plus OB equal to AB. So the total torque of the couple will be F into AB. The equation 4.8 gives the torque produced by a couple of forces F and F separated by distance AB basically. The torque of a couple is given by the product of one of the two forces and the perpendicular distance between them. Okay, now moving on to the homework part of this lecture. Okay, students, you have to write question number 4.2, part 3 and 4, and 4.13 in your NEET copies. You have to solve numerical problem 4.6 in your NEET copies, which is related to couples. Also solve related MCQs given in the exercise of chapter number 4, page number 104. I'll catch you in the next lecture. Till then, take care of yourselves. Follow all the precautionary measures. Stay home, stay safe. Thank you, students. Take care.